In this video, I'm going to explain relations. A relation is a set of ordered pairs. It can be displayed as an ordered pair, a table, a graph, or a mapping. Now we've seen ordered pairs, we've seen tables, we've seen graphs on the coordinate system, but we haven't seen mapping yet. So let's look at the relation -3, 1, -1, 0, 0, 4, 2, -5, and 4, 3. Those are the ordered pairs. As a table, we would write this as -3, 1 for the first coordinate, -1, 0 for the second coordinate, 0, 4, 2, -5, 4, and 3. On a graph, if each step was a unit, so 1, 2, 3, 4, and so on, we'd have -3, 1, 2, 3, and 1, -1, 0, 0, 4, 2, -5, 1, 2, 3, 4, this one goes a little off the graph, and then 4, 1, 2, 3, 4, and 3, 1, 2, 3. So that is what our coordinates would look like when they're plotted. Mapping, you would have your x on your left and your y on your right, and you would write all the x values. So we have -3, -1, 0, 2, and 4. Those are all of our x values. Our y values are 0, 1, 3, 4, and -5. So for a mapping, you would just draw a line between the lists that would connect the ordered pairs. So the -3 goes with the -1. So you go from -3 and draw a straight line to -1. -1 goes with 0. So you go from -1 to 0. 0 goes with 4. So from 0 in the x to 4 in the y. 2 to -5. So 2 in the x to -5 in the y. And 4 to 3. So this diagram represents mapping, which is just a way to show a relation. Let's look at an inverse relation. An inverse relation is simply flipping or switching the x and y coordinates. Our x's become y's and our y becomes x's. If we used our same relations that we used before, we would rewrite the ordered pairs as 1, -3, flipping the x and y's, 0, -1, 4, 0, -5, 2, and 3, 4. So you can see, all I did was switch my x and y coordinates. So now in the table, we'll have 1, -3, 0, -1, 4, 0, -5, 2, 3, and 4. Graphing that will be 1, -3, 0, -1, 4, 0, -5, which would be over here, and then 2, so approximately there, and then 3, 4. Now, if you remember a previous graph, which was the red coordinates, which was the relation before we found the inverse relation, if you were to draw a straight line on the y equals x axis, you can see that these are just reflected over this. So it's almost like a mirror on each side. So this red coordinate was reflected to this blue coordinate right here. So you can see that originally this was -1, 0, and it became 0, -1. So this -1, 0 became this 0, -1. We can even look at this coordinate right here. This would be 0, 4, and it became 4, 0. 0, 4 became 4, 0. It's just a reflection over this diagonal line, which is y equals x. Now let's see how we would map this. Our x is on the left now, and our y is on the right. What used to be our y's are our x's, so this now becomes 1, 0, 4, -5, 3, and what used to be our x's becomes our y's. So this is -3, -1, 0, 2, 4. And the same thing, we're going to connect them with a line. So 1 is with -3, 0 is with -1, 4 is with 0, -5 is with 2, and 3 is with 4. In the order you write your x's and y's does not matter. You just cannot have repeats within the individual circles. So if I had 2 zeros in the x, I would only keep 1 0, but just I would map it twice if it was with a different y.